Hey everyone, as promised, I can't be there with you, but I've got a little fun avatar in my place. Yeah, I realized this is the first video you've actually seen because the last time I made it, something happened and you were basically unsupervised for a day. Please note, this package might seem very thick, but know that after maybe the first three, or maybe the first four sides, the rest of it is all practice. But don't be fooled. This is all practice I need you to do. Understand? These equations, we're going to go through how we can grab them in one shot. Well, that's a lie. In one, two, three shots. Okay? We're going to take a look at what the A value does, what the H value does, what the K value does. We're going to layer it on top of each other, and we will have a final product. And we will test it using Desmos right here to show that our system is actually working. Okay, that's our goal. And so please, I'm gonna ask the substitute teacher to pause if students request to pause. So please don't hesitate to raise your hands. Be like, oh, can you give me like 10 seconds if you need to copy something? So while I'm talking, while I'm filling this up, I want you to know that there are three things we're going to do, three key points anytime you see an equation. There's three things you're going to be looking for and three things you're going to do for us, for yourself, to graph. Okay. So as a reminder, we know that the a value is going to multiply. In other words, it's going to make things tall or stumpy. I guess it's going to stretch or compress the parent function. In negative values as well, it's going to sort of include it in the same process. The h value translates the parabola left or right, so you take every single point, and essentially the x values will shift to the left or the right. And the k value translates the parabola up or down. In other words, it's going to change the y value, it's going to move it up or down. All right. So some of you might be scribbling away trying to record this. While you are doing that, know that we are going to start graphing y equals x squared. So by this point, you should sort of have it done by memory, right? We kept on talking about, hey, do you know the perfect squares? 0, 1, 4, 9, 16, 25, 36, 49, 80, 64, 81, 100, so on and so forth. All the numbers in a multiplication table that are essentially squares, right? I think I've done this before. You know, when you have like 1, 2, 3, 4, 1, 2, 3, 4, all the numbers that multiply itself, these are the perfect squares, and you should know them by heart, really. So let's do this. Completing the table, since there are 1, 2, 3, 4, 5 slots, I'm going to put the 0, x value of 0 in the middle, going to 1 and a 2, as well, -1, -2. Right off the bat, without doing any math, you should know that the parent function is just the square of the x, which means 0 squared, 1 squared, 2 squared, -1 squared, -2 squared. If I wanted to do more, it would have been 9, 16, 25, so on. Okay? So this is it. How are we going to do the a values? I'll put a little note here, but it's easier to see it in action. So as a note, just basically say multiply the y value by a. Whether it's a positive or negative, you're just multiplying with a. Next, the h values. The h values, you're essentially adding or subtracting h, add or subtract the x values by by h. And the k values, once again, it affects the up and down. So we are adding or subtracting the y values by k. But that it was probably going to sound really confusing. Like, it's very difficult to decode the math when I write it in words. So I'm going to show you in action. But for now, would you please draw me your parent function? Show me that you can do it even without looking at the chart. So pretend you're like me. I'm not cheating. I'm not looking at the chart. I know that if x is a 0, I start with a y value of 0. And then it's 1 squared, that's 1. And then 2 squared is a 4. So I'm literally just doing 1, 4, 9, so on and so forth, right? By memory. I don't need to do anything else. And same thing here, negative 1, 1, 4, 9. Let's see if I can draw a nice curve for this. And remember, don't do a V. Try to intentionally draw a U. It'll do you good. There you go. That's not bad. Okay. So at this point in time, we can pause the video if anyone needs to. But for the sake of the video itself and being short, I'm going to move on. Please turn the page when you are ready, and you will see a full summary of how every single letter affects the parabola. As I said, H is a left and right thing, K is a up or down thing, A is a stretch or compression, and a negative value of A is a reflection. Okay? So how does that all come together? Typically, when you are doing this graph, sometimes you are going to be tempted to do the easy numbers. Like, I know how to move left and right. I know how to move up and down. I'll do the multiplications last. That will give you the wrong function. All right? Here's a key. If you're going to forget anything, or if you're going to forget everything, here's one thing I don't want you to forget. When you are graphing a parabola, a quadratic equation, please transform your parabola from left to right like you were reading a sentence. So my A value here is a negative 1. Do this to your parent function first. Your H value then is a positive 1. Do this to the parent function next. And your K value is a 6. Do that to the parent function last. Okay? So what does that look like? Let me do it first, and then let me write it out in words what's happening. Okay? Here's my function. A is negative 1, H is 1, K is 6. Start by graphing the parent function without looking. So once again, 0, 0, 1, 1, 2, 4, 3, 9, 0, negative 1, 1, negative 2, 4, negative 3, 9. But instead of drawing a solid line, you know we're going to change this. I would recommend you draw a dotted line to remind yourself that this is going to change. This is not the function I'm ending with. This is where it was. Have you ever seen one of those comics where someone has to run away, so all you see in the next comic slide is a silhouette? Like, for example, you're like, hey, how's it going? It's like, hey, somebody stole my car, blah, blah, blah. And then if he was actually the thief, the person looks this way and then looks back that way. And then all of a sudden, the next comic slide has this to show that the person is missing. Have you seen something like that? It's sort of like what I want the effect of this to have. Okay, so draw a dotted line. Oops. Okay, sorry about that. Draw a dotted line. Now, let's apply my A equals negative 1. Okay, my A equals negative 1 means everything is reflected. How will we do that in an easy way? Multiply every y value with negative 1. So this point is 0, 0. Can't really see that because the thing is not right. That point is 0, 0. The y value is a 0. What is 0 multiplied by a negative 1? 0. Which means even if I multiply this by a negative 1, my point is right here. Okay? But things change. here, the point is 1, comma 1. My y value is a 1. Multiply this by -1. Where is my new point? My new point is -1. Oh, wrong color. -1. You get me? Let's go up here. My point next on the in the parent function is 2, 4. And my y value is a 4. If I reflected this, vertically reflected this by -1, essentially multiply that 4 by the -1. My new point is 2, -4. Right there. And you guessed it, as you see this pattern, I think you can do a shortcut. 3, it's not 9. 3 is -9, somewhere down here, right? I'm not even going to do that. You can cheat at this point. You have 3 points. Why not use my knowledge of line of symmetry and draw a point here and draw a point here? So my new reflected curve, reflected parabola, oops, is that. And for the record, I'm going to write y equals a -1 times x squared. This is -1 times x squared. Just to confirm, let's go to Desmos. You ready? If y equals x squared is my parent function, y equals -x squared is my upside down. So we're doing it right. Okay, let's keep going. What's my next transformation? From my pink, I must move to the right by 1. So I hope you have practice. You know that if the h appears negative in the function, it's because the h is actually a positive value. So here we go. Every x value is going to move to the right by 1. But instead of adding by 1, I think it's easier to look at the point and say, okay, this is my pink. I am moving to the right by 1. How about I do a square this time? This is my pink. I move to the right by 1. This is my pink. I move to the right by 1. This is my pink. I move to the right by 1. And this is my pink. I move to the right by 1. And if I draw a dotted line, it's going to look a little trippy. Oops. But it should give you a certain sense of satisfaction. Okay, so this green is what? Y equals -x minus 1 squared. And your final so far is not done yet, but my final so far should look something like this. And as a confirmation, I'm going to check Desmos. My next line, y equals -x minus 1 to the power of 2. Ta-da! There it is. So I think we're on the right track. Let's take a look. At this point, maybe some people need to catch up. If the substitute could pause the video if the students need it. But for the sake of video itself, I will continue. The last transformation. So this time I'm going to do it in, I guess, black for the final bit. Okay? For the final confirmation in a solid color. The last transformation, I am translating vertically up by 6. So this one, because it's a vertical, I am shifting up by 6. All right? So my green squares are there. I'm going to zoom out a bit because I'll need some space. My vertex used to be 1, 0, 1, 0. It is now going to be shifted up by 6. 1, 2, 3, 4, 5, 6. This is my new vertex, and it is 1, 6. It used to be 1, 0, now it's 1, 6. I hope that makes sense. Does that follow our little trick with your h and k value, where you can identify your vertex using that? I think it does. So let's do it. My other green squares are here. So 1, 2, 3, 4, 5, 6. Here. So that's 2, -1 is 1, 2, 3, 4, 5, 6. It's now here. And then where else? I have 3, -4. 1, 2, 3, 4, 5, 6. I have -1, -4. 1, 2, 3, 4, 5, 6. And if I take a look at those black dots and I try to draw a nice curve, that's it. And this is my y equals -x-1 squared plus 6. And as a final confirmation, let's see if we graphed it correctly. Y is equal to -x-1 squared plus 6. Whoa. Yeah, it's up there. We don't see all of this because we finished it off with a little arrow here, right? But I think we're doing it right. So opening upwards, open down, open down, open down. If we look at our diagram, let's do a side-by-side comparison. If I can grab this window without causing much trouble, right? Am I even able to do this? Error in the provided viewport. Why? Oh. I don't understand. Why is it doing that? Anyways, I give up. Let's not do that. So that's the entire lesson. But it's one thing to watch me. It's another to actually navigate your way. Every single equation is going to be a little different because the numbers are different, obviously. Let's try this one. I will do this slow one more time. And then I'm going to ask the substitute to pause the video so that you can try this on your own and see if you could do it in, let's see, 1, 2, 3 minutes. Because I don't expect you to take a long time drawing your parent function. So take a minute to do your A, a minute to do your H, and a minute to do your K, and then I will do it very quickly. Okay, so first things first, let's do this very slow. Turn the page. We're doing the new function, y equals half x plus 2 minus 5. Before anything else, I'm doing my parent function. Okay, so I'll use blue once again. 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, and -3, 9. Got it. I feel like this is the hardest part, drawing a curve. So that is my y equals x squared. All right, now, tip number 1, draw from left to right. Okay, so my a value is half. I have to multiply everything by half. My h value is a -2, so I'm moving to the left. And my k value is a -5. I'm going down. And I will graph it. I will transform it in this order. So all my y values are going to be multiplied by an a value of half. So right now my y value is a 1. If I apply my vertical compression by a factor of half, notice how I'm using the words. If I apply my vertical compression by a factor of half, my 1 becomes half, and my 1 becomes half. My 4 becomes 2. My 4 becomes a 2. And my 9, because I'm halving it, becomes 4.5. And my 9 becomes 4.5. So I've got me a compressed or a flattened parabola. This is y equals half x squared. Oops. Okay, let's keep moving. My next value is h, and that is a -2. It looks like a +2 in the function, so the h value is a -2. I am moving 2 to the left. 1, 2. This pink, 1, 2. This pink, 1, 2. That pink, 1, 2. This pink, 1, 2. This pink, 1, 2. And that pink, 1, 2. All right. With your newly drawn points, see if you can draw a nice curve. And once again, I feel like the horizontal shifts are always a little bit trippy because you're making a sort of like a parallel cup, sort of like blurring sound waves or anything like that. It's a little bit funny. We've got y equals half x plus 2 squared. Okay, so you shifted everything to the left. And everyone should have a very similar graph right now. Last number is the k. It's a -5, which means I am bringing it down, vertically shifted down by 5. My green vertex is 1, 2, 3, 4, 5. My green, the 2 points becomes 1, 2, 3, 4, 5, and 5. Then 1, 2, 3, 4, 5, and 5. And then it used to be 4.5, so it's here and here. So my vertex is -2, -5, and I have points -1, -4.5, 0, -3, 1, and half. Oof. There, something like that. It's not the cleanest, but it gets the job done. X plus 2 squared minus 5. Okay. So let me come back to this. I'm going to summarize this very quickly. If you could, as I said before, if you can go back to the very, the front of the second page, this is the steps. Just as I demonstrated so far, please always start with the parent function. Parent function. Sorry, parent graph. Okay, I'll say instead of parent function. Parent graph, please draw it. Perform the transformations in the following order, one at a time. And I will say, please note, I did this together. So you can do it together for your test if you want to. All right? I don't mind. I don't know about the other teachers, but I give you permission for my class. So there it is. But if you insist on doing it separately, you do your vertical stretch or compression by a factor of the A value. You do that first. You multiply it by a large or a small number. Then you do your vertical reflection about the x-axis. The words about the x-axis is the same as saying you use the x-axis as the mirror. You flipped it on the x-axis. Another way you can imagine it is if you have like a person here, you are going to rotate that person as if it was on a rotisserie spit, and this person gets spun upside down. You get what I'm saying? It's reflected about the x-axis. Next, And again, I give you permission to multiply the a as a negative value if you want to. Next, we will do the left right. We do a horizontal translation, aka a shift, left or right by h units. And lastly, vertical translation or a shift, up down by k units. And this is it. So I'll leave this here, and then in about 15 seconds, I will swing down to the question we just did. And at that point, I would like the substitute to pause the video and give everyone exactly 4 minutes to transform the next question to the right on their own. Okay? So if you need, please pause this, assuming that you have done so and you've copied this down successfully. I'm going back to my most recently done question, and it looks like this. Please pause the video here so that people can copy this again. And if you are done and you're happy with what you have, start with this question. Okay, I'm going to do it super fast. And so you don't have time to wait on me. Try it. You have exactly 4 minutes. Go. I'm assuming everyone has paused the video and finished it, and you're waiting with anticipation to see if you got it right. Here's what I would expect your test question to look like. Firstly, before anything else, parent function. 1, 2, 3, 4, 5, 6, 7. At this point in time, again, for the sake of speed, I'm too tired. You know what? I shouldn't set a bad example. Here it is. Okay, don't be lazy like me. Do your best to be clean, because you know if you do 3 other graphs, it's going to get messy anyways. Next, let's do pink to be consistent. I have a -1, so I'm going to flip it. Immediately, 0, 0, -1, -1, -4, -4, and -9, -9, which I don't have. There you go. That is my y equals -x squared. What's my next transformation? It is to the left by 2. So my pink would be to the left, to the left, to the left, to the left, to the left. It should look like this. And that is my y equals -x plus 2 squared. And my last number is +5, and that is my final. So being a +5, don't get it twisted, that is in fact upwards in the positive direction by 5. My vertex is now here. My vertex are here. -4, I go up by 5, it's here, and it's here. So my final curve is that. So y equals -x plus 2 squared plus 5. Yeah. So I hope you got it. Please note, all of this is practice. Practice on practice. I'll try to finish this myself and upload the answers for your viewing pleasure. I'm not sure if I want to do all the transformations or just give you the final bit. We'll see how much time I have in hand. You can also check with Desmos to see if you got it right, of course. Use your online resources whenever possible. It's really helpful. And helpful hint for the future, if you remember yesterday's handout, there are some really good questions from the word problem set. Okay, 4.2, rather, let me point you to 4.1. If you go all the way back to our Tuesday homework, the very end questions, like here, it's number 6, where it doesn't give you an equation, but you have to sort of piece it together. These kinds of questions are excellent. So please take this time today, and we're going to continue tomorrow, to really master transformations and just graphing parabolas in general. Okay? And that's it. The video is going to be found online, so use it to your advantage. Otherwise, suffer well, and I'll ask me questions tomorrow. Okay? I will see you then.